Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're going to talk about the second method in addition and subtraction of vectors, which is called the head-to-tail method. Some textbooks call it the triangular method or triangle method. So you can see different names for it, but they basically mean the same thing, okay? So please try as much as possible to review the previous video. So this is the second method. I talked about the previous method, the first method, which was when all the components are known. Now, this is the second method in this series. So make sure you review the first method before you come to this video, okay? All right, so before I proceed, don't forget to like, share, and subscribe. If you've not clicked notification bell, I don't know what you're waiting for. Please do so that when I post new videos, you'll be the first person to know, all right? So let's get cracking now. So the first thing is that you have to know is that this method shows that two vectors can be added together by placing them together in such a way that the first vector head joins the tail of the second vector. Thus, the first vector tail and the second vector head can be obtained to get the resultant sum. Okay, so if you have, let's say, I want to add two vectors A and B. All right, I needed to add two vectors A and B. So let's say I want to add vector A is something like, maybe we'll have something like, this is vector A, okay? And we had another vector B, all right? So if I want to do it, so what I'm trying to say is that you get vector A. So this is the, remember we talked about in the previous video that in a vector, this part here is the head, while this part here is the tail, all right? So if vector A, this is vector A's head, and this is vector A's tail. So what I'm going to do, I'm going to then add the tail of vector B to that of vector A. So if I now move from the tail of vector A up to the head of vector B, that is going to give me the sum of the two vectors. Does that make sense? So I'm going to write this down so that it will be easy for you to understand as well. Okay, so the first thing is that just a quick reminder about head and tail of vectors. So we talked about this earlier. So if you have a particular vector, this part of the vector is the tail, while this part of the vector is the head. Okay, so it can be written in different forms. You can write it like this. So if it's written like this, the same thing. This is going to be the tail, while this is going to be the what? The head. Okay. So with that being said, so how do you now add the vectors? So I'm going to write that down. So basically, this method shows, all right, this method shows that two vectors can be added together by placing them what? Together, okay? In such a way that the first vector head uh, joins the tail of the second vector. All right? So thus, by joining the first vector tail to the head of the second vector. we can obtain the resultant sum. Okay, so what I'm trying to say, so if you have vector A, okay, and you're adding it to vector B, now if you move from this point to this point here, okay, it's going to give us, so this is, let me put it this way, maybe that will help. Use another different color. So if you now move from this point all the way to that point, okay, so this is going to give us the vector what? A plus B. Okay, A plus B. So I'm going to show you now the three methods for adding and subtracting. Okay, so there are 3 steps or 3 rules. So we'll talk about that now. You can say the 3 steps or the 3 rules for doing this. Number 1 is that or maybe I can make it up to 5 so that I can combine both the addition and subtraction. Maybe that will be save me some time and just combine the 5 steps together. So the first thing is that the 2 vectors A and B have to be placed together. So first, the 2 vectors A and B are placed together. Okay, in such a way that the head of A connect to the tail of B. Okay, so what I'm going to do, yeah, I'm going to break this into 2. So if we're adding and if you're subtracting. So what the first step I'm going to talk about now is if you're adding, okay? If you're adding, then we'll go to step 2. Okay, step 2 is for adding now. So if you're adding, so after you combine both of them together, so if you're adding, this is what you do. So then to find the sum, a resultant vector C is drawn in such a way that it's going to connect the tail of A to the head of B, okay? Then to find the sum, a resultant vector C is drawn in such a way that it connects the tail of A with the head of B. Okay? Then number 3, the sum is then expressed as C is equal to A plus B. So what I'm saying, similar to what I just did earlier. So if you have, we have this particular one. So let's say we have A, or put this way. So we have something like this. We have A, okay? We connect both of them together. And this is B. Then the resultant sum, so we'll call this C, will be equal to what? A plus B. Easy, all right? Now, so what we just discussed now is when you're adding. What about when you're subtracting? So how do you go about that when you're subtracting? So when you're subtracting, okay, when you're subtracting, what do you do? Now, in this case, what you do is that the resultant sum, instead of you have to add the negative of the vector, okay? And how you remember in the previous, when I told you the negative, you have to change the direction. So you have to reverse the direction of the vector, but you have to still maintain the magnitude of that vector. So if you have, for instance, if we have a vector, let's say we have a vector like this, 5. Now, remember, if you're looking at the negative of this vector, is going to be in this direction. Okay, and this is going to be what? -5. Are you seeing it? So what you do, so if you have another vector this way, you have a vector, let's say 3, okay? Now, if you're doing the negative of that vector, basically, you reverse, you keep it, but it's going to be in the other direction. Is that making sense? So we talked about this, but if you reverse the direction, okay, then it's going to be a negative sign. So that's exactly what is expected of you here as well. So then to subtract, add the negative of the vector which is done by simply reversing the vector's direction. So remember, you're reversing, okay, the vector's direction, but keep its magnitude. The same. So that means in this case, the magnitude is not going to change, but you're going to reverse the direction. Is that okay? The direction is being reversed, but the magnitude stays the same, okay? Then when you've done that, then you add it to your vector head. To tail, okay? As you would normally do. So that is step 1 to 3, okay? Okay, so step 1 to 3, or you can do just step 1 to 3. So it's technically everything there, okay, as you normally do. And that is step 4. Then the next step, step 5, when you've done with that, the subtraction is then expressed. Let me see, is this step, I think, okay, step 1 to 2, not 3. I put it step 1 to 2. Okay, so the subtraction is then expressed as a resultant sum as a vector what? D. Okay, so what we are saying is that D is going to be A plus B, but because we know that plus times minus will give you minus, so that means it's going to become A minus what? D. So see, at the end of the day, we've subtracted. So let me try and see if I can just draw something. So let's assume we're told to do A minus B. Is that making sense? So A minus B. So this is the same thing as saying, okay, A plus minus B. Is that making sense? So A minus B, the same thing as saying A plus minus B. So generally what we are saying is that if this is the A, so if this was the A, okay, ideally the B was like this, right? This was the B. But we are not looking for B, we're looking for minus B. So the minus B is going to be in this direction. So this is going to be minus B. So that means if you now join this point here to this point, it's going to be D will be equal to A plus minus B. And that will be the same thing as what? A minus B. Are you seeing it? So normally where the direction of the B, you just flip it, but you just keep the magnitude. All right. Okay, so let me pick some examples here. Okay, so we're told add the vector below. Add the vectors A and B below to find C, then subtract, or let's put this as another. This is the first one. So we have this. So the first one was add them together to find C. Number 2, subtract B from A to find D. Okay, we have something like this. Subtract B from A to find D. And the vector that was given, this was the vector. It was like this. Okay, we're told that this is 3, 2, and this is 4, 1. and we're now told, so this was A, and this was vector what? B. All right. So we're gonna do this together. So as usual, I'm gonna see if I can do it by the side here. Okay. So we're asked to do A plus B. All right, A plus B. So we're doing the head-tail method. But in this case, okay, in this case, the what we're looking for, the coordinates are known. So it's very easy. So we're gonna have this one, and we have this one, all right? We have this to be 3 and 2, and we have this to be 4 and 1. Okay, so this is A and this is B. So we can then, so the answer for this will be A plus B here, right? Okay, but the coordinates are known, so it's going to be easy, straightforward. So we're going to be A plus B, okay? What you then do, you just use the coordinate. So we write this again in the form of what? 3, 2 plus 4, 1, okay? And this is now going to give us 3 plus 4, then 2 plus 1. And this is going to be what? 3 plus 4 will give you 7. 2 plus 1 is going to give you what? 3. And that's the answer for that. So you can write it like this, or if you want to, you can write it in this form, 7, 3. Is that okay? But I usually prefer the column method, all right? Good. Now let's do the other one, number 2, okay? Let's assume we have this. So number 2, we're told to find A minus B. Okay, subtract B from A, so A minus B. So the same thing I told you, this is the same thing as saying A plus minus B. So if we look at this, we had this one here. Okay, the A is what? 3 and 2, 3, 2. Okay, now the B we had here was 4, 1. Okay, so this was the B. So remember, the magnitude stays the same, but the direction will change. So therefore, for this one, we're going to have the B now is going to be in this direction. So the B now is going to be minus, so this is going to be minus B. This is plus B. This is going to be minus B. So it's going to be minus 4 and minus 1. Are you seeing it? So definitely, the solution we're looking for is from here to here, which is going to give us the D, which is going to be A. So the D is going to become A plus minus B, and that'll give you equal to A minus B, right? So we're going to add these two together. So it's going to become A plus minus B. So that means the A, so D is going to be equal to A plus the negative B, all right? So the A, we have the A to be 3 and 2 plus our negative B is minus 4 minus 1. Are you seeing it? So we can now solve this now. So it's going to be equal to 3 plus minus 4 and 2 plus minus 1. And this is going to give us 3 minus 4, 2 minus 1. Then 3 minus 4 will give you minus 1. And 2 minus 1 will give you also what? Minus 1. So this will be the answer. Or if you want to, you can put it in the bracket form as -1, comma, -1. And that will be the answer as well. Okay? All right, so that's how you add and subtract vectors, and that has been sorted. I'm going to move to the next video, which will be the parallelogram method, which is the third method. All right, so it's very important that you subscribe and also click on notification bell so that when I post the next video on parallelogram method, you'll be the first person to know. So if you have any question or you're confused, please try as much as possible to get back to me. Send me an email or drop me a comment, and I will get to you as soon as I can. All right, see you soon. I'll see you in the next video.